Okay, we're covering two sections today. The first one is properties of parallelograms. For this section, it's explaining the properties of parallelograms. If you know it's a parallelogram, these are the properties that it will have. You can sometimes see this in your directions. Sometimes it'll actually tell you that. One way or the other, these are the four properties. If you know it's a parallelogram, it will have all of these properties. First two are pretty self-explanatory. Opposite sides are congruent. These two sides have the same length. These two sides have the same length. Opposite angles are congruent. These two angles are the same. These two angles are the same. These two are a little bit tricky. Consecutive angles are supplementary. Consecutive means next to each other. So these two add to 180. These two add to 180. These two add to 180. And these two add to 180. All consecutive angles are supplementary. The last one, be careful, can cause you to think incorrectly. So it says the diagonals bisect each other. So if this is my parallelogram, this green line cuts this orange line exactly in half. The green cuts the orange. It works the opposite way. The orange also cuts the green exactly in half. That's what it means by they bisect each other. So this green cuts this orange into two equal pieces. The orange cuts the green into two equal pieces. The diagonals bisect each other. The mistake that you guys are going to make is when you look at this, you're going to assume that all of these little lines here are going to be equal, and that's not necessarily true. So bisecting each other is a different idea than each of these diagonals having the same length. So be really careful you don't make that mistake. So looking at our first sets of examples, it says find the value of the variable in the parallelogram. The directions tell you that it's a parallelogram. Therefore, we know all of these red things are true. The first one, obviously we're talking about the angles, so we know that opposite angles are congruent. So when I set this up, these opposite angles are congruent, so I can say 106 equals 9b minus 2. So again, using your idea to set up your equation, and then of course solving it. Adding 2 to both sides, and dividing by 9, b gives you 12. Now that we know what this one is, we can plug that in and say that these consecutive angles are going to be supplementary. And there's more than one way to approach this problem. We can say 9 times 12 minus 2 plus 7a minus 3 equals 180. So this angle plus this angle is supplementary. They're next to each other. We need to simplify this. So this ends up giving me, what's 9 times 12 minus 2 minus 3? What's that give me?
103.
103. So I simplified by combining all of this. 103 plus 7a gives me 180. 180, I'm going to move this 103 over, and I get 77. Divide by 7, and I get a equals 11. So again, I'm using these properties because I know it's a parallelogram to find the value of those two variables. This problem, these are the diagonals bisecting each other. For these problems, be careful if they give it to you in a book or a test or workbook or whatever. Sometimes they write these little expressions in a weird place and you're not sure what they're labeling. So sometimes they put it up in here and you're not sure if they're labeling this or even this. If you're not sure, just ask me and I'll clarify for you. Okay, so we have lots of stuff going on here. We need to figure out a good starting point. So I know that these two segments are congruent because their diagonals bisect each other, but this is not a good starting place. This segment is 2t plus 5. This one's 9v minus 13. It's not a good starting point because we have two different variables. We can start with these two. They're going to be congruent and they have the same variables, so that's a good starting point. So I can say 8t minus 30 equals 4t plus 6. Moving my t's to the left, I get 4t on the left. Moving the 30 to the right, I get 36. So t equals 9. Now that I know that t is 9, I can plug it in and use it for my next step. So now I can set these two equal to each other. I know that t is 9. And then the other side of the equation is 9v minus 13. I can only set this up because I now know that t is 9. So on this side, I get 23. Move my 13 over. Divide both sides by 9, and I get v is 4. So again, before you start just assuming, make sure you understand why. It is a parallelogram, which allows us to use those characteristics as properties. Okay, let me keep moving on to 8.3. So in a way, they go hand in hand. 8.2 is all about if you know it's a parallelogram, then we know that those red properties are true. This is a little bit different. This says if we know it's a four-sided figure, to show that it's a parallelogram, you have to know one of these situations are true. It is slightly different than what we just talked about with 8.2. So one of these has to be true in order to call it a parallelogram. So again, any four-sided figure is a quadrilateral. A parallelogram is a specific kind of quadrilateral. I'm not going to go through all of these. You guys can read them. We're going to go through some examples. But again, one of these 6 has to be true in order to call it a parallelogram. So let's look at some examples. So these scenarios, we want to decide if they give you enough information to call it a quadrilateral. I'm sorry, parallelogram. So the first one, both pairs of opposite sides are congruent. Is this enough information to call it a parallelogram? What do you think? Yeah, this one's an easy one. This is exactly like what's over here. It's word for word. It's exactly the same thing. It's enough to call it a parallelogram. Some cases it will be like this. It'll be pretty cut and dry and easy. Sometimes you have to read into it a little bit more. So the next one says 2 pairs of consecutive sides are congruent. 2 pairs of consecutive sides are congruent. What would this look like? Any ideas? Consecutive, meaning next to. Almost like a kite. Could it also mean something like this? Are those 2 pairs of consecutive sides congruent? It could be. So do you think that this is enough information to call it a parallelogram? It is not. No. This is not enough information to call it a parallelogram. How about number 3? The diagonals are congruent. Is that enough to call it a parallelogram? I'm seeing no. I agree. Because just because the diagonals are congruent is not enough to call it a parallelogram. What if we had a picture that looked something like this? Those diagonals are congruent, but that doesn't necessarily mean that it's a parallelogram. So that one's a no. What about the last one? All 4 sides are congruent. You have to think about this one. So if all 4 sides are congruent, it's obviously going to look something like a square. Is any of these true because all 4 sides are congruent? What about both pairs of opposite sides are congruent? Look at my picture. Are these opposite sides congruent? Mm-hmm. Absolutely. Are these 2 sides congruent? Mm-hmm. Absolutely. So just because it's not exactly spelled out, by saying that all 4 sides are congruent, this scenario is true. This is a good example of don't just read it, understand what it's saying. Okay, so this last one is a yes. Look like some of you guys were shaking your heads no. Does that make sense? Okay. The last one, it says show that the given points form a parallelogram because the opposite sides are parallel. Well, let's think about this. First of all, how do we know if lines are parallel? Or what do we need to know to decide that they're parallel? This is review from a previous chapter. They have the same slope. If they have the same slope, then they're parallel. Well, we need to find the slope. It's not given to us. Does anybody remember the slope formula?
Oh, y equals mx plus b.
No.
And oh, slope-intercept.
This is your y equals mx plus b. This is your slope-intercept formula. We need slope formula.
Wait, is it the y minus y1? Oh no.
y2 minus y1, x2 minus x1. Remember, change in y over change in x. Do you guys remember that? I'm gonna go quickly through these problems, but if you need me to help you out a little bit more with it and go over some more examples, I'm happy to do that. So we're gonna find the slope of AB, the slope of BC, the slope of DC, and the slope of AD. I'm hoping to show that those opposite sides are parallel, and that's enough to show that it is a parallelogram. With me? Okay, so let's start with AB. Let's find the slope of AB. My change in y, 0 minus 7 goes on top, 3 minus negative 4 on bottom. Again, I'm gonna go through this quickly. If you need help with it, I can help you guys. On top is negative 7, on bottom is 7. That simplifies to negative 1. Slope of BC, change in y on top, change in x on bottom, so look what I did. y2 minus y1, x2 minus x1. On top gives me negative 5. On bottom, change flip, gives me negative 1, which in turn is a slope of 5. Slope of CD. On top we have 2 minus negative 5. On bottom, negative 5 minus 2. So on top is 7, on bottom is negative 7. When you simplify, that becomes negative 1. My last one, I'm going to find the slope of DA. Change in y on top, 2 minus 7. And on bottom, negative 5 minus negative 4. On top, 2 minus 7 is negative 5. On bottom, negative 5 plus 4 gives me negative 1. Simplify that by dividing, that gives you 5. So slope of AB is negative 1, BC is 5, CD, and DA. So you can see that the opposite sides, these two sides have a slope of negative 1, which means they are parallel. These two sides have a slope of 5. They have the same slope, which means they are also parallel. Make sense? Remember your slope formula? Okay. You do have 2 sections to cover with note homework for tonight. You do have 1 quiz that covers both of these sections next time I see you. I'm going to be assigning your project here in just a minute that has copies of everything on Schoology. And that's it.